Alright, welcome to today's lesson on finding limits of indeterminate forms. This is going to be just a short lesson because this is one of those concepts that's pretty simple in concept, but just takes some practice to get used to. So the lesson will be short, and then we'll give you some opportunity to practice as we go. So first of all, let's make sure we understand what an indeterminate form is. This is an indeterminate form is a form where the limit yields 0 divided by 0 when you attempt to use a direct substitution. We saw last week different rules for when you are allowed to use direct substitution, and here's a case where it may not have fit one of those exact rules, so you went ahead and tried it and you get 0 over 0. So this is how you can attempt to evaluate those limits. Now, one note before we even get started is that if neither of these will work, or if neither of these are possible, then what you need to do is use the table on your calculator to evaluate it. Looking at the graph on your calculator can help you estimate it as well. And again, remember, when we do that, those are estimates. They're not precise solutions, but as we saw before, you can get pretty good estimates off of those. All right. So the two methods we're going to look at today are the dividing out technique and also the rationalizing technique. And rationalizing, particularly when we have radicals involved in the function. But let's take a look at both of these. First of all, the dividing out technique, you'll notice we have a limit as x approaches 1 that we want to find of this function x minus 1 over x cubed minus x squared plus x minus 1. And of course, since it's something that you may or may not be familiar with, the first thing you would try would be to substitute in and try direct substitution, but you'll notice we get 0 in the numerator and 0 in the denominator. If we just got 0 in the numerator, that would be okay. We could just say that the limit equaled 0. But since we get it in the numerator and denominator, we need to try something else. So, since we have a binomial in the numerator that can't be factored, we're going to try to factor the denominator, and you'll notice we have an x cubed minus x squared plus x minus 1. And what we're going to do is actually factor that by grouping. Now you could try, since the whole point of this method is to divide out, in other words, cancel the numerator out with a factor of the denominator. If you couldn't figure out how to factor by grouping, as you can see over here, factoring the denominator, we would factor out an x squared in the first two terms, and we would consider it to just be a 1 here from our second two terms. And then we have this binomial common factor of x minus 1 that we could factor out. And what's left then is this x squared from there and the plus 1 that's understood to be outside those parentheses. Again, if you can't remember how to do factoring by grouping, since the whole point of this is to try to get this right here, this canceling out, you could use synthetic division to divide the denominator by x minus 1 and see what you ended up with. And you would end up with the same result here. Okay, so you notice we factor our denominator into x minus 1 times x squared plus 1. Then we can cancel it out. Notice if we were to graph this, it actually would have given us a whole. You can actually see that here. We would have had a whole here at x equals 1. Otherwise, it was a continuous function. So we know that's a whole because it actually did cancel out. So now we are taking the limit of 1 over x squared plus 1. And the reason why that's good is because now when we use direct substitution, we don't have our indeterminate form anymore. We actually get 1/2. So we could say the limit as x approaches 1 of x minus 1 over x cubed minus x squared plus x minus 1 equals 1/2. Okay, so again, a relatively simple process, but the whole point is you've got to factor this. And you might have to get a little bit creative with the factoring, or as we mentioned before, since the point is to try to cancel something out, use synthetic division as an alternative. Okay, so that's our first method. I'll give you a little preview of our homework that I'm going to have you work on later. And you'll notice here, all of these on numbers 5 through 15 are ones where this strategy would be useful. Okay, later ones here you'll see there will be other ways that we might want to try to simplify them. Especially here with the trig, make sure you go back to some of your old notes from our units on trig. You may have to do some manipulating there to get it into a form that will not give you an indeterminate form when you use direct substitution. Okay, but then you see functions like these where we want to find a limit, but it's not something that can be easily factored. And like here, we really don't have anything to factor. Well, what can we do in order to find those limits? Well, this is where the rationalizing technique comes into play. Here we want to find the limit as x approaches 0 of the square root of x plus 1 minus 1 all over x. Again, this is an indeterminate form because if we use direct substitution, we would have the square root of 1 minus 1 is 0, and the denominator would also be 0. So that gives us an indeterminate form. So how do we rationalize, and what are we really talking about when we're talking about rationalizing? There's no way to get rid of radicals entirely in this fraction. But this is actually a good strategy, whether the radical is in the denominator or the numerator. If you get an indeterminate form by direct substitution, then look at your numerator in this case, and we're going to multiply the entire fraction by a form of 1 using the conjugate. Okay, we needed a different strategy from direct substitution, so we multiply by the conjugate. Notice this was the square root of x plus 1 minus 1, so now we have the square root of x plus 1 plus 1. Okay? Now, why do we do that? Well, you'll notice here we can FOIL the numerator, so the square root of x plus 1 times the square root of x plus 1 is just x plus 1. Because they're conjugates, the outers and the inners will cancel out. And then we have a minus 1. So we have x plus 1 minus 1. And then our denominator we would just have multiplied as it is. Okay? So as we simplify, looking at the numerator, that simplifies down to just an x. And once again, we have something that cancels out here. And basically, you'll notice what's canceling out is the thing that makes the function an indeterminate form, or that 0 over 0. It's where the 0 in the denominator comes from that ends up getting canceled out. Okay, so you see here again we have a hole. Okay, you can see it in the graph, and you can see this x getting canceled out. Now, note please that x still cannot equal 0 for the function itself. We still keep the domain that we had from the original function. But now we do have a form where we can use direct substitution. Even though the function's not defined at that point, we use the direct substitution by plugging in 0 for x, and that'll tell us what our function approaches. We have 0 plus 1 is 1, square root of 1 is 1, so we have 1 over 1 plus 1, so 1/2. Okay, so that's our second indeterminate form and how we would handle that. Again, if you have a radical like this and you get an indeterminate form, try multiplying by the conjugate, and often you'll end up getting something that you can cancel out so that you can then evaluate by direct substitution. However, if neither of those work, again, you can always estimate using the table. Alright, so that's all for the lesson. Now it's just a matter of practice. So, with your partners, go ahead and work on these 5 through 27, the odds. It is on the PDF online. If you can't find it, you can see them right here. So you could just pause the video. Also, 53 to 60 are these problems. Here, note, you're determining the limit by evaluating the one-sided limits. In other words, the left and right-hand limits. Okay, so a graph would be helpful, whether by sketch or using your graphing calculator, and then evaluating the limits using the left and right hand limit. Especially be careful with these piecewise functions down here. You'll need to graph both pieces, and just please take note of where you are using each one, each part, since your calculator doesn't really graph just part of it. You're going to have to look at it and see what areas you're on which function. Okay? Alright, so that is all, and have a good time practicing. We will go over all of these and questions from earlier problems that you might still have during our Fusion Day lesson.